All right, we're going to start talking about acids and bases a little bit. And the way we're going to approach this is a little different than we've approached anything else. I found this fertilizer manual here a few years ago, and I think it's one of the best ways through which we can begin talking about acids and bases. And so we're going to use this kind of to get you to find how this is relevant in our real world, okay? And I'm going to kind of read some of this stuff, and it's accessible to you on the Teacher Wiki site, so I would suggest you download it as well. If you want to print it off and mark it up, I would suggest you do that, especially the first 10 pages or so. And I've also supplemented some stuff here from the text, okay? So we're going to go through this. But it talks about, like, soil pH here is one of the first things that they discussed, okay? In order to understand what pH is, you have to understand what acidity is. And what I really love is the definition here. So it says, and I'm going to read along here, what is soil acidity? In terms, or in simple terms, an acid is defined as a substance that tends to release hydrogen ions. So when you look here, a substance that tends to release hydrogen ions. That's something that you guys are used to, okay? When we went through naming acids and bases, for example, we have hydrochloric acid, HCl, which we have to say the AQ, okay? We put that in water, that's going to form hydrogen ions and chloride ions. Okay, and you guys all know that, so that makes that very, very simple. So that definition of an acid being a hydrogen ion producer is one that's pretty darn easy to understand. Conversely, it talks about a base. Okay, conversely, it talks about a base. All right, a base being one that produces hydroxyl ions. Now, we didn't call them hydroxyl, we called them hydroxide ions. And once again, you guys know my writing is outstanding. Then we call them hydroxide ions. So when we start talking about bases and we look at the simple type of base that we deal with, okay, sodium hydroxide is one of the bases that you guys have referred to or known about quite a bit. And once again, this says AQ. Okay, AQ, so keep that in mind, okay? So we'll get rid of this here and kind of keep going on here. It said all acids contain hydrogen ions, and the strength of the acid depends upon the degrees of ionization or the release of hydrogen ions of the acid. Some acids are classified as strong acids, okay? Strong acids because they are highly ionized, or they release a lot of the hydrogen ions when dissolved in water. Examples of strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Other acids are classified as weak acids because they slowly ionize, okay, or release those hydrogen ions. Examples of weak acids are carbonic acid and citric acid. Now, this kind of stuff is really, really cool when you start thinking about, okay, what kind of an acid should I use? Or strong or weak? And what are some of the effects of this, okay? Another thing to keep in mind here when it says that all acids contain hydrogen ions. Okay, that's not technically true, and we're going to talk about that in just a second here, but that's not technically true. We're going to go through a chart that shows the definitions of acids and bases here. Keep in mind that we are referring to something that's used by, your everyday ordinary person. So the knowledge of an acid and a base, according to that type of a definition, is different than the knowledge of an acid or a base in the science realm. So for all intents and purposes, if you understand it conceptually that an acid is a hydrogen ion producer and a base is a hydroxide ion producer in aqueous solution, then you're going to be okay. But there are differences between them, okay? Good stuff. And it also talks here about like examples of weak acids and strong acids. There's a lot of stuff dealing with buffers that really allow your knowledge of weak versus strong to come into play that are going to be pretty fun. So let's go on to the next slide. Now, as I said before, when you look at the different definitions of acids and bases, this is a chart from your textbook. I can't remember what page, but it's in table 19-4, so you guys can go look that up. But they look at the different types of definitions, okay? And the reason these definitions came about, the Arrhenius, the Bronsted Lowry, and the Lewis, is because you really can't just consider an acid and a base in such simple terminology as it relates to as it relates to chemistry. So you have to have a little bit more complex information in there, all right? So we can't make anything easy. But like we said before, an acid is a hydrogen ion producer, and that's following that Arrhenius definition. That makes sense. And the same thing with the base being a hydroxide ion producer. So this is what your fertilizer manual said. Okay, this is the definition using that fertilizer manual. Okay, now the Bronsted-Lowry is a little bit different. The definition for a Bronsted-Lowry, it says a hydrogen ion donor. Okay, which makes a little bit of sense too if you think about it. So these are going to be essentially the same. Okay, in terms of the Bronsted-Lowry and the Arrhenius acid, from the perspective of you have a hydrogen ion being either produced or donated, okay? But then you look at the Bronsted-Lowry definition of a base, that's a little bit different. That Bronsted-Lowry definition of a base says it's a hydrogen ion acceptor, a hydrogen ion acceptor. So that makes things a little bit different in terms of that definition, okay? Now, when we look over here at the Lewis, okay, the Lewis definition of an acid and a base, this is a more generalized way of looking at acids and bases, not just from a hydrogen ion perspective or a hydroxide ion perspective. Okay, the Lewis acid and base says basically a Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. Now, that seems a little confusing if just on the surface, but really it isn't. Okay, so like when you look at how can like hydroxide, fit into this in terms of it being an electron pair donor. Well, if you look at hydroxide, all right, it's going to have that negative charge, so it's going to have extra electrons available, okay, where a hydronium ion or some other positively charged ion can associate itself, right? So your book had a pretty good example of that, and we're going to show you that here in a second. In your book, it talked about identifying Lewis acids and bases, and there is this one problem associated with that in conceptual problem 19.1, and there's some others below it. But they go over, okay, now what can be a Lewis acid and what can be a Lewis base? Here's the question here, and that question says, ammonia is widely used as a fertilizer in plastics and explosive. Identify the Lewis acid and the Lewis base in the reaction. And when you look here where it says analyze, the Lewis acid, Lewis base definitions, which are to be used in solving problems, are based upon the acceptance and donation of pairs of electrons. And remember, a Lewis acid is an electron pair acceptor, and a Lewis base is an electron pair donor. Okay, so and they talk about how to solve the problem here. It says ammonia is donating those electron, or that pair of electrons, and you see this right over here in this example. Okay, those electrons are being donated by that ammonia. Okay, all right, so that follows along here with the definition. Okay, the boron trifluoride, this second substance over here, which is separate, okay, is an electron pair acceptor. Okay, so here the ammonia is going to act like the base. All right, the ammonia is going to act like the base, okay, and the boron trifluoride is going to accept that pair of electrons, and it is going to be the Lewis acid. Once again, it is accepting a pair of electrons, okay? So that's kind of a demonstration about how those definitions are a little bit different from one another, all right? One of the biggest takeaways you're going to get from all of this is, as you consider an acid, if you just remember essentially that an acid is a proton donor, you're going to be in pretty good shape, okay? Because if it's a proton donor, all right, it's also an H plus producer. So that makes it very, very simple. So if you think about hydrogen, guys, and we've talked about this in the past, okay, hydrogen in its pure form, if you have protium, okay, that particular hydrogen, what you have one proton, and then you have one electron, okay? Now, if it gets rid of this one electron right here, all you have, okay, is this one proton. That's all that's left. That's all that is left. Okay, so when you think about that, to say that hydrogen is a proton donor or an H plus ion producer, it makes perfect sense. So get that in your head and keep it in there. all right? Don't worry too much about the Lewis acids, other than the fact you have to know that there are different types of definitions depending upon the situations. If you're good with understanding an acid to being a proton donor, okay, or a hydrogen ion producer, you're going to be just fine.